We test code in isolated server environments, but digital products are deployed into the chaotic, high-density reality of human interaction. Traditional offline benchmarks evaluate software capability through task completion. They run an agent through a trajectory and measure whether it passes a battery of unit tests to establish functional correctness. That binary success metric misses the variable nature of the user. It abstracts away how different people tolerate response latency, how they formulate their requests, and whether they continue trying after an AI hallucinates an answer. An expert user might want terse responses and complete autonomy from an agent. A novice completing the exact same task requires detailed explanations, small edits, and constant confirmation. Live human testing captures these behavioral differences, but recruiting, scheduling, and collecting data from real users takes weeks, making it too slow and expensive to scale alongside rapid development cycles. To evaluate a system effectively, engineers need infrastructure that measures how a diverse population interacts with an interface, rather than just confirming the task is technically solvable. This is the design problem MatrAIx solves. It is a population-scale evaluation infrastructure that tests digital products using 8.3 billion simulated persona records. These records are not the result of arbitrary prompt engineering. Every simulated user is mapped to a rigid schema containing 1,290 distinct categorical dimensions. The schema quantifies human variation. It covers specific variables across background demographics, psychological traits, technical capabilities, behavioral patterns, and lifestyle preferences. The system populates this framework using two complementary methods, extracting human-grounded profiles and generating synthetic populations. Nearly 600,000 of these profiles are anchored in empirical real-world datasets. The records are extracted directly from sources like Wikipedia biographies, Amazon reviews histories, and the General Social Survey. To maintain strict privacy standards, the pipeline strips all direct identifiers, like names and contact information, from the human-grounded records. Only the extracted demographic and behavioral attributes remain. Anchoring the schema in measurable human data ensures the resulting population reflects empirical reality. This prevents the evaluation from skewing toward the internal biases of the language model generating the simulation. Extracting existing data provides an empirical baseline. The engineering challenge is scaling that into billions of synthetic profiles without generating contradictory combinations of human traits. To solve this, MatrAIx generates personas by forward sampling through a directed acyclic graph. This graph preserves topological correlations. Demographic probabilities link to previously generated variables. Assigning a geographic region adjusts the probability for primary language. It also enforces logical constraints. Someone whose primary language is English cannot have a proficiency of none. The simulation engines sample sequentially down the graph, across all 1,290 dimensions, resolving local dependencies until the record is complete. The output is a contradiction-free, hyper-specific persona ready to evaluate a product interface. Mapping these demographic dependencies ensures the synthetic users behave in ways that reflect real-world cohort variations. Once the population is established, MatrAIx samples a target cohort for a specific application. It assigns large language models, like Claude Opus or GPT 5.5, to power the agents representing those personas. The system deploys these agents into the MatrAIx playground, an interactive infrastructure containing 4 testing environments. The first environment handles surveys. Agents complete questionnaires for market prediction or concept testing, calculating how a specific income bracket reacts to a $2 price increase on a retail product. The second environment is the AI chatbot, testing conversational UX and latency tolerance. Interaction shifts based on the persona's schema. An agent with a peanut allergy and vegetarian diet forces the chatbot to adapt its meal plan in real time. This interface demonstrates the third environment, web. Computer use agents autonomously navigate browser windows to assess product recommendations, comparing options based on their assigned budgets and needs. The final environment evaluates apps. Agents operate as simulated users within a native desktop sandbox or mobile simulator to test UI layouts and feature discovery. This screen shows a complex financial software interface where the agent is tasked with researching specific stocks, evaluating the graph, and adjusting security settings. Across all 4 environments, MatrAIx captures comprehensive telemetry. It logs exact keystrokes, dialogue turns, task durations, and verifiable outcome states. These parallel sandboxes generate actionable data on human-like interaction pathways, bypassing the logistical delays of clinical human trials. The utility of this infrastructure relies on a single validation metric. Do the language models actually adhere to the behaviors dictated by their 1,290-dimension profiles? To verify this, engineers ran a 400-trial controlled study across all 4 environments, explicitly measuring behavioral adherence to assigned attributes. The system successfully expressed or correctly suppressed the declared persona traits in 366 of those trials, achieving a 91.5% adherence rate. This scatter plot illustrates how adherence produces useful cohort data. During a meal planning task, MatrAIx tracked how demographic variables influenced outcomes. The telemetry isolated friction points. Empty nesters showed a 20% higher likelihood of following the meal plan than career changers. Because the agents reliably follow their persona schemas, developers can use this data to pinpoint interface failures affecting specific demographic subgroups that aggregate scores typically hide. Simulated users do not eliminate real testing. MatrAIx is a hypothesis-generating engine. Final product retention must still be validated by human subjects. The advantage is iteration speed. Engineers run controlled, reproducible trials in parallel, exposing corner cases and testing interface variations in hours rather than weeks. By modeling complex demographic variables at scale, developers can locate points of friction and optimize software before a single human user ever interacts with it.